We are the EcoLogic team, and we know is that as climate change increases, there's a tendency for hurricanes and more natural disasters, where the contribution to climate change can be energy usage in data centers. But as we start increasing our need for data centers with the advent of artificial intelligence, we need more efficient artificial intelligent implementations that can help to scale down the power and resources needed for artificial intelligence. Our solution is to focus on a topic of neural symbolic artificial intelligence, which essentially learns a circuit using machine learning that we can deploy on an FPGA to both reduce the power consumption and inference time of these systems. We can use IBM Watson to monitor a fleet of these real-time prediction systems so that anytime abnormalities or threats are detected, we can prepare individuals and first responders who are in harm's way. At scale, this approach can help to reduce the energy needs and the carbon emissions that are required to scale artificial intelligence. We have a demonstration of our work in these following videos.
25 different models over here. All the code can be found out on GitHub that is attached to the project submission. Upon training, we ran inference. We have recorded all the accuracies, and then after that we start to convert this logic gates, the learning logic gates, into Verilog and VHDL, so that this could be communicated to the hardware. And then we can predict the classes with the hardware, as Nabi is going to show, and then we can show that they align correctly with this. So currently,
yeah, so right now we have Model 2 on the FPGA. We were able to convert it all into Verilog, flashed it to the board. Right now the images are being stored on the onboard SRAM. And basically right now we're showing index 0 of that SRAM, which is going to correspond to this first picture. And you can see that this classifies it as a 5, just like that one. Then if we want to do the next address, classified as a 0. The next one's classified as a 4, a 1.
Hey, so this is the part of the script where we run the data analysis. Essentially, the FPGA is going to be sampling the data, so we're going to detect a new state. The DAD board is going to sample that, send it to the laptop, and it's going to prompt Watson. Watson is going to give us an update about that, depending on the state that's been detected. So you can see here that a new state was detected and a new Watson prompt was made. A new state can be activated again synthetically by changing the switch, and you can see there that it was detected, and now it's being prompted a new Watson prompt.
And so this shows us that we have the ability to read from the DAC system and then send this to IBM for real-time monitoring. Results from this demonstration show that as the network size increases, the inference time typically increases as well. However, when we implement on the FPGA, we're noticing that we have anywhere from a 62% to a 78% reduction of inference time, showing that as we scale these systems larger and larger, we can make a real difference on real-world systems. So together, we think that these approaches can help us secure the skies with both EcoLogic and IBM Watson.